reflection. Total internal reflection is a scenario where a traveling wave of light strikes a boundary of a medium but an angle that is larger than the critical angle. So the concept behind is that if the refractive index on the other side of the boundary of the medium is lower and the light wave strikes at greater angle, so the wave is reflected internally entirely. Total internal reflection is a basic concept used in a variety of applications for fast traveling of light rays. Total internal reflection can also be extended onto various concepts that arise out of it, like frustrated total internal reflection or evanescent waves, which are the special cases of this phenomena. Critical angle. Critical angle is a specific angle where if the light travels from denser to rarer medium, at this angle it goes in a straight line across the boundary. To understand better this phenomenon, we use ray diagram. In the figure show, a ray of light AO is traveling from denser to rarer medium with small incidence angle. That is, when the ray reaches into rarer medium, it bends away from normal ON and refracts with an angle R in the rarer medium and goes in direction OC. In the figure, ray diagram to explain critical angle when ray of light bends away from the normal in rarer region. The angle of reflection in rarer medium is greater than the angle of incidence I in the denser medium. By increasing the angle of incidence in denser medium, the angle of refraction R in denser region increases gradually. For a certain angle of incidence, angle I is equal to C, the angle of refraction in rarer medium becomes 90 degree and thus known as the critical angle. We should know the critical angle of glass, which is 42 degree, which means when we will incident a ray at an angle of 42 degree and then only we will get an angle of refraction in air as 90 degree. The critical angle for a medium is thus defined as the angle of incidence in the medium for which refraction angle is air is 90 degree. The critical angle is denoted by letter C.
Conditions for total internal reflection. The light ray should pass from denser medium to rarer medium. The angle of incidence should be greater than the critical angle. For an incidence angle greater than the critical angle, there will be no refraction of light from denser to rarer medium. Instead, the light rays get reflected back to the denser medium itself. Applications of total internal reflection. Total internal reflection is primarily used in the field of fiber optics. The structure of optical fiber makes the total internal reflection possible. There is a difference in refractive index of core and cladding, which makes it possible for ray of the light to reflect internally. By using this technique, the light remains trapped in the optic fiber cable, and this phenomenon helps in fast transfer of light down to the entire length. Optic fibers are mainly used in the field of telecommunication, where there is a requirement of making it to travel through long distance without getting lost or distorted. Hence, light will always be reflecting from the layer of cladding having lower refractive index regardless the angle that the fiber bends into. That is, the shape of the fiber cable, which may even take the shape of a circle.
Another application of total internal reflection is in medical science, where this concept is applied to endoscopy tests where there is need for light to reflect internally. Prisms used in binoculars uses this concept to show erect images. Optical fingerprinting is another application used to record the image of the fingerprint. LED light panels are also based on the principle of total internal reflection. Diamonds partly get their brilliance and sparkle from the concept of this total internal reflection. This is because of the high refractive index of the diamond, which is 2.3. So the diamond achieves its shine when the light ray strikes many internal surfaces of the diamond due to its cut, and then at one particular incident when the angle is less that critical angle of 25 degrees, it escapes from the medium and emerges into the air. This is the cause when the colors of the light get separated and are shown brilliantly. Some of the major applications of taught internal reflection include controller of the automatic windshield wipers in the case of rain sensors, used in spatial light filtering, used in prisms that are used in binoculars in order to show the images erect. These are very useful in the recent technology wherein multi-touch screens are used which use the concept of frustrated taught internal reflection to sense different targets at the same time. A fluorescence microscope that uses this principle based on the evanescent waves excite the material fluorophores to closely monitor and observe biological samples. Prism can also be modified in order to observe taught internal reflection. Conclusion. Taught internal reflection is a phenomenon which is involved in various practices of our lives unknowingly and is cause of various applications in our everyday lives. Its symbol occurs because of the difference in the refractive indices of two mediums which are bundled together and hence light traps in between them due to some specific angle of incidence greater than critical angle. Therefore, it is really important to have a deep idea about taught internal reflection in order to understand the underlying principles of various things such optical fibers, endoscopy and variety of routine things too. Taught internal reflection hence forms basis of various other phenomena that help in medical science, telecommunication, etc.